Okay, then I want to welcome Annika Schroder from the United States. Oh. And you got him.
Hi, my name is Annika Schroder. I'm from the US, and the title of my research project is Which Side Are You On? The Complex Relationship Between Autophagy and Arsenic Neurotoxicity. And so first of all, we want to know, why do we want to study arsenic? Well, humans are exposed to arsenic chronically throughout our lives through a multitude of ways, including through drinking water, and pesticides. They often include arsenic as an element for compounds. And additionally, we are also exposed through just dirt. It's in the earth. And so, as you can see here in this chromatogram of the United States, arsenic is highly concentrated throughout the United States, and so we want to understand how it's affecting our bodies, because it has been linked to a multitude of diseases, including cancer, diabetes, and neurodegenerative diseases like Alzheimer's and Parkinson's. And so we used astrocytes, which are a type of neural cell, for our study. And the reason why we use astrocytes is because astrocytes are the first line of defense for foreign molecules entering the brain. And so the overall objective of this project was to understand if inhibiting or activating pathways for degrading damaged proteins affects the magnitude by which arsenic is a neurotoxin. And so we did this through Western immunoblotting and flow cytometry. And the protein degradation pathways that we were looking at were all three of these, but for this project, I specifically focused on autophagy. And autophagy is a protective pathway, so it's thought to help cells when they're under stress conditions, and they will then take damaged proteins and recycle them and degrade them so that they're able to maintain the homeostasis within their cells, so the internal cell environment. And so autophagy focuses on the formation of an autophagosome, which is where proteins that are damaged will be degraded. And so it's important to remember that autophagy is considered a protective mechanism, and it helps cells survive when they're under stress. But what we found for our research was that inhibiting autophagy actually decreases the toxicity of arsenic. So arsenic is considered a toxin, but when we were stopping this protective pathway, we saw that cells were actually living at higher concentrations of arsenic. So here we inhibited the formation of the autophagosome by inhibiting the formation of this complex with a chemical called wortmannin. And then we also inhibited the formation of the autophagosome using a viral vector, DNATG5. And what we saw was that cells were living at higher concentrations of arsenic with both of these conditions. So in both of these different experiments, we saw that no autophagy increases it increases how cells are like living, how they're surviving, which is contrary to what people would expect. And additionally, we were able to do this and show this through another activation of autophagy. So we did this using a viral vector to inhibit autophagy through the AMPK pathway. And then for that, we saw that there was also increased protection at higher concentrations of arsenic, which just goes to show that autophagy may actually be increasing the toxicity of arsenic. And another thing is that that's why the name of my project is Which Side Are You On? Because we also saw that by inhibiting autophagy through these two complexes, which are mammalian metabolic proteins, that they actually lead to sensitization. So they actually lead to decreased cell viability. So really, this project is interesting because for the first time it shows that autophagy may not be a protective effect, and it may actually be increasing the toxicity of arsenic. So thank you.
Thank you very much. Are there any questions? Yeah, there is one question.
So this autophagy, it's happening in the cell, I assume.
Yeah.
And you're inhibiting it.
Yes.
So if you're inhibiting like properties of the cell, are you sure that this won't have like bigger consequences?
Right. Well, that is also another possibility. So possibly by inhibiting autophagy, we may be activating other protein degradation pathways, which may be a reason why cells are actually surviving. So that is one thing to consider, yeah.
Thank you.
Mm-hmm.
Any other question? Up there. I'm sorry. Could you raise your arm again? Yeah, perfect, thank you.
What's your end goal? Where do you see this going?
Yeah, so I'm no longer working in this lab, but I believe they've continued on with it. And really the importance of this project is to understand like the cellular mechanism behind which arsenic acts as a neurotoxin. So then it can give us more information about how to possibly prevent neurodegenerative diseases from forming.
I think there was one more question over there. No, a bit more down, and then, yeah, on the left.
Do we know what factor makes it more or less common in an area?
You mean for arsenic?
Yeah.
Well, arsenic is in the Earth's crust, so it's concentrated throughout the world. But in specific places, I would assume that agriculture will have an effect on if it's in your drinking water or not. So in the US, a lot of farmlands have higher concentrations of arsenic in the water.
Okay, thank you.
Any more questions? Okay, all right. One question down here. Over there.
Hello. What will happen if you eat a piece of arsenic?
Yeah, so
Is it like your muscles?
I'm not really sure, but when you do have acute arsenic poisoning, there are like obviously there are some health effects and it's toxic, but this study was more for like low grade exposure to arsenic.
Okay, because
Yeah.
a Swedish king long ago was killed with arsenic. So
Yeah.
I just wonder how he died. No.
I can't tell you, I don't know, yeah.
Because I have studied that calcium channels in how do you say, nerves, nerve cells.
Yeah,
If they are broken, some people might
yeah,
die because the muscles keep on tensioning the body.
that's possible, yeah.
I wonder.
I don't know anything about acute toxicity,
Okay.
but yeah, this is more chronic low exposure.
But it's dangerous.
Yes, it is a toxin, yeah.
Thank you very much.
Thank
very
you.
nice.
Thank you very much. Okay, thank you.